Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. Today we're going to look at exponents, the two major types of exponents that I like to put on either side of a column so we can compare the different methods. They're very different. All right, so first thing we need to notice is that here our bases are multiplied and the fraction is divided. So if we multiply or we divide, we're going to use prime bases, and then after we have found prime bases, we're going to move the powers up and gather the powers. Right, this side here we are adding and subtracting, completely different methods. So if you are adding or subtracting, you're going to do a highest common factor after you have split. Right, so let's go back to the first one. I have got 4, which is a power of 2. So it will be 2 to the 2 into 2y minus 1. 9 is 3 squared into y plus 1. And 18 is the problem. 18 is 9, which I would write as 3 squared times by 2. So 3 squared times 2 is 18. And then 8 is 2 cubed. The 2 cubed must go into y minus 1. But now over here, when you split 18 into 3 squared and 2, each one gets the y. So let's just highlight that, please. 18 to the y gives us 3 to the 2y, 2 to the y. You are welcome to take extra steps to do that, but that would be the quickest, probably safest method. Right, so now we're going to distribute the 2 into that bracket. So it's going to give me 2 to the 4y minus 2. Here, 3 distribute the 2, 2y plus 2, all on 3 to the 2y, 2 to the y, and here 2 to the 3y minus 3. Right, we are now ready to gather all the powers. So base 2, I'm going to gather all the powers, and the ones I take up from the denominator will change sign. So it will be 4y minus 2. Here's another 2, so minus y minus 3y plus 3. Then we're going to multiply by the 3 and gather all of its powers, which is 2y plus 2. And here's another 3 in the denominator, minus 2y. So I'm quickly going to see the y's normally would cancel away, but that is not all the time. So please don't think that the y's will always cancel. So 4y minus 4y gives you 0. 2y minus 2y gives you 0. And we are now left with 2. To the 3 minus 2 is 2 to the 1. And here we left with 3 squared. So our answer is going to be 2 times 9, which is 18. Right, so that is a very common question, and it has a method all of its own. Now we're going into the other type where you are adding and subtracting your bases. So adding and subtracting in any part of maths in high school is always a little bit trickier. I can see a 2 to the x, a 2 to the x, a 2 to the x, and a 2 to the x. I need to split those 2 to the x's away from their other powers and then take it out as a highest common factor. So that's going to be 2 to the x times 2 to the 3 minus 3 times 2 to the x, all on 3 times 2 to the x, 2 to the minus 1 plus 2 to the x. Right. I can now see my 2 to the x, which I can take out on top, and 2 to the x, which I can take out on the bottom. So from that, I'm going to take the 2 to the x out, top and bottom. When I take it out of the top, please put that minus sign in the middle. And when you take it out of the bottom, very important, put that plus sign in the middle. Right, and we are left with 2 to the x is gone, we're left with 2 cubed. Here, 2 to the x is gone, we're left with 3. Here we are left with 3 times 2 to the minus 1 is a half. And then here's the most important. 2 to the x out of itself leaves you with a 1. And that is the big worry, that people miss that. Right, so that's why I say put the signs in so that you know that you've got to have something on either side of the signs. 2 cubed is 8 minus 3 on. 3 times a half is 3 on 2, which is 1.5. So let's write it as 1.5 plus 1. We know you're going to use your calculators for this. You're left with 5 on 3 on 2 plus 2 on 2 is 5 on 2, which we are going to tip and times and get 5 times 2 on 5, which cancels down and leaves you with 2. So I hope you can see the methods are completely different, and you need to look at the question carefully before you rush in and start. Right, hope you've learned something. See you in the next video. The lesson today is going to be identities with a combination of compound and double angles. Right, question 1. Question 1 is going to be sine x plus sine 2x, sine x plus sine 2x on 1 plus cos x plus cos 2x, cos 2x, and we're trying to get that to equal tan x. Okay, left hand side is the more complicated, so we will start with the left hand side, and the first thing we notice is we have a double angle here, which is going to use this double angle over here, and we have a double angle of cos here, which we have to make a decision. Right, so making the decision. This cos double is connected to a cos single, and if you look at tan, tan is sine x on cos x, and the denominator has a cos. So I have 2 guidelines to tell me to use the bottom formula. There's a guide and there's a guide. So it's not just guessing, it's a little bit more mathematical than that. Right, so in the numerator we're going to take out sine x, not yet, sine x plus. Sine 2x is 2 sine x cos x And in the denominator, we've got 1 plus cos x. And we are going to use the cos that only has coses, and that is plus 2 cos squared x minus 1. Right, and then plus 1 minus 1 give us 0. So now we're going to go and look at the numerator. The numerator has got a common factor of sine. So we're going to take it out. Sine x leaves me with 1 plus 2 cos x. And in the denominator, I have a common factor of cos x. And that's going to leave me with 1 minus 2 cos x. And those are the same, and they will cancel. Right, and I'm then left with tan x, and therefore left hand side equals right hand side. Question number 2 is cos 2p on cos p minus sin p. And that has to equal cos p plus sin p. Right, again I have that double angle of cos. What is going to guide me? My guide is going to be the right hand side is a mixture of sin plus cos, and in the denominator I have another mixture to guide me. So from that, my guide is actually going to be the cos squared minus sin squared. Right, so left hand side, cos 2p is going to be cos squared p minus sin squared p, and the denominator is cos p minus sin p. Right, something to notice is that formula is dots, and we use dots often, difference of 2 squares. Right, so the numerator is going to be difference of 2 squares, cos squared p, I have lost it, cos p minus sin p, cos p plus sin p, which does have its own special name, not that you have to know it, but that is called a conjugate pair. Right, divide and you'll be left with cos p minus sin p, and that cancels with that, and we are left with cos p plus sin p, which is exactly what we want. Cos p plus sin p, and then that is left hand side equals right hand side. Question number 3 is cos to the power of 4 theta minus sine to the power of 4 theta equals cos 2 theta. The left hand side is more complicated because of the high powers and the subtraction, so I'm going to start with the left hand side, and it is dots. So that will be cos squared theta plus sine squared theta, cos squared theta minus sine squared theta, also known as a conjugate pair. Right, cos squared plus sine squared is 1. And cos squared theta minus sine squared theta is cos of 2 theta, and therefore my left hand side equals my right hand side. Number 4, very important one, 1 minus sine 2x on cos sin x minus cos x equals sin x minus cos x. Right, very important. I'm going to carry on up here. I'm going to do left hand side, and I see I have a double angle of sine, so that's the first thing I'm going to change, and I'm going to get 1 minus 2 sine cos. 2 sine cos. Right, and put that over sine minus cos. Okay, now something very important for you to recognize is, if I have a mixture, it is normal and common to change the one, the constant. So if you have a mixture, you will normally keep the mixture and change the one. The reason for that being, trinomials or quadratics, x squared plus 3x plus 2 is a trinomial that has one variable, x, 1 and 2, plus plus. But you can get a trinomial that has got two variables, which is x squared plus 3xy plus 2y squared. That is a trinomial with two variables, x, y, and factors of 2 that add up to 3 is 2 and 1, and both positive. Now in trig, you need to notice that we have a mixture. Here we have a mixture. So when you have a mixture with a constant, it is common to write that one as sine squared plus cos squared, and put the rest in the middle, which is your minus 2 sine x cos x. So we're going to rearrange it and put it in the middle. This is very common, so please don't ignore this question. Sine x minus cos x. Right, that's going to give us the sine squared in the front, the minus 2 sine cos in the middle, and then the plus cos squared at the end, and we have made ourselves a lovely trinomial. Now, just to deviate a bit, if this one had been a 7, you would write 7 sine squared plus 7 cos squared. If it was a 10, you would do 10 sine squared plus 10 cos squared, and then carry on. They would have given you other numbers which will work out into a beautiful trinomial. So let's go. Sine x, the beginning of each, cos x at the back of each, and to add up to negative 2 needs a negative and a negative. Right on sine x minus cos x. And that sine x minus cos x cancels with one of those, and you are left with sine x minus cos x. Left hand side equals right hand side. Right. Number 5. Let's have a look at this one. It is cos x on 2, which is a half x, plus sine x on 2, which is another half x, and all of that is squared, and they want us to get that to equal 1 plus sine x. You can work right to left, but it would be better to work left to right. So left hand side, I'm going to square a binomial. You can write it out twice and do FOIL, or if you know how to do the shortcut, that would be great. So my left hand side would be cos squared x on 2 plus multiply and double. So 2, I like the sign x on first and then the cos x on 2. There's my middle term, and then plus sine squared x. Right, then we're going to go cos squared plus sine squared is 1, and here 2 sine half cos half. Looking back up here at this turquoise formula, 2 sine single cos single is sine double. So here 2 sine half cos half is going to be, all of those make up sine of x. Therefore my left hand side equals my right hand side. We will cover more of these in the future. So I just want to say thank you for listening, and I hope you've learned something, and please wait for the next video. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.